Hello kid. Once again we are here to solve the assignment of the chemistry regarding the 10th class. Today's assignment topic is rules to write the electronic configuration. So in this assignment you will be having the questions asking regarding the electronic configuration of certain important elements and the rules to write this electronic configuration. So coming to the first question, after filling the 3s orbital, electron enters, you will be having 3p, but not 3d. Explain. What is the rule we have to follow here, and we need the explanation. So once again I repeat the question. After the electrons entering into the 3s, the electrons will enter into the 3p but not 3d. He is asking the rule. Which rule is violated, or which rule we have to be followed here? The rule that have to be followed is half-bow rule. According to the half-bow rule, the electrons enter into the orbital with lower n plus L value. Low n plus L value. So this is the rule. So you can extend this rule also. If at all n plus L value is same, then electron enters the orbital with lower n value. So coming here, we have to observe now the n plus L values of 3s, 3p and 3d, so that we can explain the answer for this question. So writing the n plus L values, write for 3s, 3p and 3d. For 3s, n plus L value. N represents the 3 principal quantum number and L represents the orbital. L value for s orbital is 0, so n plus L value will be 3. Next is n plus L value for 3p orbital. N value for 3p is 3 and L for p orbital is 1. So here 4. Coming to the 3p orbital. The 3p orbital n plus L value is, n value is 3 and L value for p orbital is 1. Sorry, here you have to find for d orbital. N value for d orbital, that is 5. So according to n plus rule, what we have to follow? According to n plus L rule, the electron has to enter into the lower n plus L value than to the higher n plus L value. So the 3s electrons, following the half-bow rule, first enter into the 3s. After that the electron enters into the 3p but not to the 3d, depending upon their n plus L rule. The rule followed is again half-bow rule. This is your first question. Coming to the second question. The second question, which rule is violated in the electronic configuration 1s2, 2s0 and 2p3? So this is the next question. Which rule is violated here? So when we observe here, again we are violating half-bow rule itself. Half-bow rule. What is half-bow rule? The electron enters into the lowest n plus L value first and then the highest n plus L value. Now coming to the 2s, the n plus L value then is 2. L for s orbital is 0, that is 2. Next is for 2p, n plus L value will be, n value for 2p is 2 and L value for p is 1, that is 3. So first electrons have to enter into the lowest 2s orbital and then to the 2p orbital. So this will be your explanation for second question. Coming to the third question. In the third question, he has asked to write the electronic configurations of chromium and copper. So writing the electronic configurations, chromium, first concentrate on atomic number. Atomic number of chromium is 24. So start writing 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. So one can get the doubt why I didn't complete the 4s orbital but I have went to the 3d. Yes, first here they violate the Hofbauer rule to get half-filled configurations. 4s is in the half-filled configuration, 3d is in the half-filled configuration, and so whenever we have a half-filled configuration, it is termed to be the stable electronic configuration. So to attain the stable electronic configuration, the chromium and copper will violate the Hofbauer rule. So this is the configuration, or else till here it is orgon configuration. So I can write 4s1, 3d5. Now coming to the copper. Copper atomic number is 29. So again writing in the same manner, 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. Here also, instead of completely filling the 4s, I have completely filled the 3d. Why? Because here 4s will be half filled and 3d will be full filled. So coming here, again half filled configuration and full filled configuration are stable. So in order to attain the stable configuration, it has violated the rule. So though it has violated, since it is a stable configuration, it is allowed configuration. So this will be 4s1, 3d10. So coming these are the configurations for chromium and copper. Coming to the next question. Next question, that is fourth question. The correct electronic configuration of an atom. He has given two electronic configurations here for us. In these two electronic configurations also, we have to observe and we have to find why it is correct. The correct electronic configuration of an atom is given. Correct one. Correct one is given as 1s2, 2s2, 2px1, 2py1 and 2pz1. And the wrong configuration is given as, he himself is telling, it is not this configuration. 1s2, 2s2, 2px2 and 2py1. So he is asking the reason here. He is asking the reason why this atomic configuration is correct and why this atomic configuration is not correct. So observing again, here the degenerate orbitals are solely filled. Here degenerate orbitals are not solely filled because here we will be having 2pz0. So going to the definition of degeneracy, we will be following here Hund's rule. According to the Hund's rule, while we are filling the electrons, all the available degenerate orbitals have to be solely filled. Once again I am repeating the rule. While filling the electrons, according to the Hund's rule, all degenerate available orbitals have to be solely filled. Then only electronic pairing starts taking place. So coming here, the degenerate orbitals of p orbital are px, py and pz. So while we are filling, first these are degenerate orbitals. What are degenerate orbitals? The orbitals having same energy are called as degenerate orbitals, or else you can tell the orbitals belonging to the same subshell will be having same energy. Such orbitals are called as degenerate orbitals. So according to Hofbauer rule, while I am writing the electrons in this subshell, First, the degenerate orbital should be solely filled and then only they have to pair. So this, according to this rule, 2px, 2py1 and 2pz1 is correct. But 2px in the second configuration, it is given just like this. Px is paired up and py is solely filled, which is the wrong representation. First, degeneracy has to be completed. Next, pairing. Here, degeneracy is not completed. First, pairing has taken place. So, this representation is wrong representation. So, coming to the next question. Next question. Draw the diagram which shows the filling of the order of various orbitals. We have to draw a diagram to show the order of filling of the orbitals. For this diagram, we will be taking the Moller's chart. Moller's chart. So, in this chart, the arrangement of the orbitals will be done in such a way that we can simply identify the lowest orbital to the highest orbital. Coming that, first write only s orbitals in a line, in a vertical line. 1s, 2s, 3s, 4s, 5s, 6s, 7s and 8s. So to draw this diagram, remember that first terminals, you have to leave the terminals and start writing from the interior one. So after s comes 2p, so again 2p, 3p, 4p, 5p, 6p and 7p. Again writing to the next line. Leave the exteriors, write starting from the next interior one. After SP, you will be getting 3D, 4D, 5D, 6D. So next, after writing that, leave the exteriors, start writing in the interior. 4F, 5F. So if at all, you observe, they have arranged in a diagonal order. So 1S first, next 2S, 2p and next after completion 4s you have to go with 3d, next 4d and next coming here the last one. So the order is the 1s will be having least energy level. So I can have 1s greater than 2s greater than 2p greater than 3s greater than 3p. Sorry, it's lower energy. 3p will be having less energy than 4s will be having less energy than 4s. After 3d, 3d will be having less energy than 4p, then the 5s, then comes 4d, 5p, then comes 6s and then again 4f, 5d, 6p and then comes 7s, after that comes 5f, 6d, 7p and 8s. So while we are filling the orbitals, first we have to fill the lower energy orbitals. So we will be starting filling the electrons from this orbit to this orbit in a series. So that these are the answers for this assignment. Thank you very much. Stay home, stay safe. Thank you.